So in this video I'm going to tell you how to prepare trichloromethane or chloroform, that means CHCl3 in laboratory, which is one of the most important and frequently asked questions of the examinations. So basically the structure of chloroform is somewhat like this. It is formed by replacement of the 3 hydrogen of methane. This is methane, H, H, H and H. CH4 is methane, and replacement of the 3 hydrogens of methane by chlorine, it forms the trichloromethane or chloroform. Basically in laboratory the chloroform is prepared by heating ethanol or acetone with a paste of bleaching powder. There are two ways, from ethanol and one is from acetone. Now both of them, they react with a paste of bleaching powder. It is heated with a paste of bleaching powder and then the chloroform is prepared. But there is stepwise reaction. In ethanol there is first of all oxidation, then chlorination, and finally hydrolysis. Here it is chlorination and hydrolysis. These are the steps of these both reactions. So the bleaching powder paste, it is acting as all three oxidizing, chlorinating and hydrolyzing agents. So we'll go stepwise. So first of all, what happens is that when you're told to write about the laboratory preparation of chloroform, first we'll write the principle. And the principle is that it is prepared by heating the ethanol or acetone with a paste of bleaching powder. In this process, first of all, this is the formula for bleaching powder. You need to remember the molecular formulas of each and every molecules, the ethanol, acetone and bleaching powder. This is the bleaching powder, CaOCl2. Okay, bleaching powder. Now for preparation of bleaching powder paste, we react with it water, and so a CaOH whole 2 is formed, Cl2. What happens is that this whole Cl2 goes out and this whole H2O adds here. So when H2O adds here, it forms CaOH, O is 2 and H is 2, so OH whole 2 and Cl2 goes out. So this is our bleaching powder paste, which is also known as calcium hydroxide. So this is the principle. Now from A, which is from ethanol. That's not ethanol, that's ethanol. So how it is prepared from ethanol? Don't get confused between ethanol and ethanol. Ethanol is different and ethanol is different. I'll tell you how it is different. See, this is ethanol. So first step is oxidation. So write oxidation first of all. Okay, so in oxidation what happens is that ethanol, the formula for ethanol is, this is ethyl alcohol ethanol, and ethyl alcohol means CH3CH2OH. okay, see the formula for ethane, it is C2H6. So for formation of ethyl we remove one hydrogen, so it forms C2H5, which is ethyl, and when alcohol is there, OH is added, so ethyl alcohol, C2H5OH, C2H5OH. so this is the ethyl alcohol. Now in oxidation we require an oxidizing agent. So oxidizing agent, here it is chlorine. Okay, so chlorine is the oxidizing agent. Now we know that in oxidation the hydrogen is removed. So this hydrogen, remember which hydrogen is to be removed. This hydrogen, the middle one hydrogen, it gets removed. Okay, so this middle one hydrogen gets removed and it forms CHO, plus this hydrogen gets removed and adds here. So see, 2 hydrogen and 2 chlorine, so it forms 2HCl. So this, what it is formed, it is an aldehyde and it is known as acetaldehyde. Now if you want to know the IUPAC name, then the IUPAC name of this aldehyde, it is ethanol. Now this is ethanol and this is ethanol. Ethanol is an aldehyde, CHO, aldehyde, and ethanol, it is an alcohol, OH. So this compound formed is known as ethanol. First of all, ethanol is formed. What happened? This hydrogen got removed, because in oxidation hydrogen gets removed. The oxidizing agent is chlorine. And if you want to make the exact structure of this, it will be CH3CH and double bond O. This is the basic structure of acetaldehyde actually. So we'll be making this structure for understanding, because at last it will be easier for us to understand. But while writing for ease, you can make this structure as well. CH3CH, just write the basic formula. So this was oxidation. Then we'll go for the chlorination. Now it's obvious, by the term chlorination we react it with chlorine. So this ethanol or acetaldehyde which is formed, we are drawing the real structure, so it is reacted with chlorine. Now balancing part you can do later on. So in chlorination what happens is that this hydrogen gets removed and chlorine adds here. Okay, so this hydrogen gets removed and chlorine adds here. Now first of all, remember that 3 chlorine is used. Okay, 3 molecules of chlorine is used. It is the balancing part, but you need to remember this to understand. I am doing it earlier to make you understand, because now what happens is that this hydrogen gets removed, and see, carbon is a tetravalent compound, so it needs 4 bonds, and due to this reason there are 3 hydrogens attached to it and 1 carbon attached to it. 1 carbon is attached and 3 hydrogen attached. So when hydrogen gets removed, 3 chlorine should be added there, replaced by 3 chlorine. So what happens is that when this hydrogen gets removed, the chlorine adds there, so it will be CCl3, because 3 chlorine adds there, and the remaining will be the same. And hydrogen gets removed and some of the chlorine is left, because 3 chlorine is there, so it forms HCl. For balancing it will be 3 HCl. Byproduct HCl is formed in both of them. In oxidation also HCl is formed, and here also HCl is formed, so it will be easier to remember. In acetone also HCl will be formed in chlorination as byproduct, so it is easier to remember that HCl is formed always. So what happened is that ethanol or acetaldehyde we call it, it is chlorined. It means it is reacted with chlorine, and then hydrogen gets removed and chlorine adds there. Even here hydrogen got removed. Okay, oxidation, here also hydrogen got removed, but here chlorine adds here. Easier to remember the basic principle. So now this compound formed, it is known as chloral. Okay, this is an important term to remember, chloral, because it will be asked even in the chemical reactions to how the chloral is formed and all. So this chloral is an important term to remember. But for Iupac name you can write it trichloroacetaldehyde. See, this is acetaldehyde, because CHO is there, so it is aldehyde, and acetaldehyde is CH3CHO, so CH3CHO. So instead of H there is Cl3, so it will be written as trichloro 3-chlorine acetaldehyde. So this is the Iupac name of this trichloroacetaldehyde, and chloral is the common name. Now this was about chlorination, and after chlorination oxidation is hydrolysis is there. So in hydrolysis what happens is that this chloral formed in CCl3CHO, this chloral formed, it is reacted with the bleaching powder paste which we created the very first. In principle we had created a bleaching powder paste which is known as CaOH whole 2. Okay, now in hydrolysis what happens is that this chloral, it is reacted with this bleaching powder paste which was formed, so it reacts with the bleaching powder paste. Now what happens is that if you write this reaction in this way, just simply in a line, it will be very difficult to remember. So I'm going to draw the structure of CaOH whole 2 to make you understand, and it will be easier to write by drawing the structures as well. So see, CaOH whole 2, so CaOH whole 2 is there, so one more OH, okay, and plus, remember 2 molecules of it is used. Here it was 3 molecules of chlorine, here it is 2 molecules of chloral, just to make you understand and make you remember. So see, CaOH whole 2 is there, and write this CCl3CHO just adjacent to this, and CCl3CHO adjacent to this. So now what happens is that we know that formula of chloroform is CHCl3, and this is the last step. So chloroform needs to be formed. So CCl3 and H, it gets combined. CCl3 and H, it gets combined. So it forms two molecules of CHCl3, which is known as the chloroform or trichloromethane. Now the byproduct formed, just add there. If hydrogen got removed, this all will add there. Hydrogen gets removed, this all will add there. So it will be CaOOCH, OOCH, OOCH. You can also write COOH. We know COOH means formate. It means formic acid. So it is known as calcium formate. While it is not necessary to remember the name of this byproduct, just for information I told that it is known as calcium formate because COOH is there and calcium is there. So calcium formate, and this is our basic trichloromethane or chloroform which is formed. Easy enough, just oxidation takes place, hydrogen gets removed, and acetaldehyde is formed or ethanol is formed. Remember both the names, it will be much easier for you to write in examination. Even if you forget one name, you can remember another name, because in organic writing the names is very very important. So CH3CHO is formed because hydrogen got removed, okay, and then this CH3CHO, it reacts with chlorine. Chlorination is another. So again hydrogen gets removed and chlorine gets added there, and 3 chlorine will be added. Don't write 2 chlorine seeing here, because carbon is a tetravalent compound and it requires 4 bonds, 1 bond with carbon and 3 bonds with either hydrogen or chlorine. So this is known as chloral. Now chloral, it reacts with our bleaching powder paste which we created the very first by reaction of CaCl2, which is known as bleaching powder, with water. Then drawing the structure, it will be much easier. See, CaOH whole 2, so one more OH, and draw 2 chloral here adjacent to both of them, and then make this bracket. It will be easier for the examiner to understand. So it will form CHCl3, and the remaining one just add there. So this was about preparation of chloroform from ethanol, but still acetone is left, so we'll go for the acetone now. So we know that in acetone there is no oxidation, directly chlorination and hydrolysis. So first of all chlorination occurs, but before that we need to remember the structure of acetone. We remember the structure of ethanol, and the similar way we need to remember the structure of acetone. Now acetone is actually much easier to understand, means remember its structure. It is simple, CH3CCH3O. This is the real structure which we will be using, but if for remembering it is just CH3COCH3, CH3 on both sides, just add CO in between, okay. Now it is a type of ketone, because in ketone, this is the basic structure of ketone, CO, both the sides something is added, so it is known as acetone because CH3 is added. CH3 means methane, and the common name of methane is, sorry, not actually common name, usually when we use methane and when we use the common name of methane, we use acid, this term, and then acetone or acetaldehyde, anything, but this ACET, acid, it is related with methane, okay. So it is known as acetone because CH3 and CH3 is added in the ketone. So first of all chlorination occurs, so we'll draw this structure for CH3 CCH3O. So we know in chlorination it is reacted with 3 molecules of chlorine. In chlorination we reacted with 3 molecules of chlorine. So again we will react with 3 molecules of chlorine. So it is similar to that of the preparation from ethanol. We removed the hydrogen here and added the chlorine here. The same thing we are going to do that. Remove the hydrogen, add the chlorine. So it will form, I'll write here, it will form CCl3 CCH3, remaining one will be same. See, again the same thing, remove the hydrogen, add the chlorine. So the process of writing name is also similar. See, it formed from acetaldehyde and 3 chlorine was added, so it was known as trichloroacetaldehyde. Here also it formed from acetone and 3 chlorine is added, so it is known as trichloroacetone. That formed from acetaldehyde, so it is known as trichloroacetaldehyde. It formed from acetone, so it is known as trichloroacetone. The naming is also very easier in this. And then hydrolysis occurs, which is the second step. So in hydrolysis, again the same thing, this trichloroacetone, it is reacted with CaOH whole 2, but again we'll draw structure wise just to make it easier to understand. So make CaOH whole 2 again and draw the same thing structure here adjacent to it, CCl3 CCH3O CCl3 CCH3O. Now add these both, H and this, so it will form two molecules of CHCl3, and the remaining one just go and add there, plus OOCH3 COOCH3 CCH3, and again OOCCH3. So this is our chloroform, and this is known as calcium acetate. Just for information, not only to write the name, just otherwise it will be difficult to remember the other names. So it is known as calcium acetate, though I told you, and this is known as chloroform. So this is the basic principle of preparation of chloroform by both acetone and the ethyl alcohol or ethanol. Now this was about the principle, but then when we write about the lab preparation, we also need to write about the procedure. So for procedure, first of all we need to make a basic figure. The figure will be of a round bottom flask on a water bath and on a Bunsen burner, and then a condenser will be connected to it with a separating funnel at last. So this will be our basic structure of the figure. Just make a round bottom flask on a water bath and a Bunsen burner, and then make a condenser and then the receiver. So while writing about the procedure, we need to remember that the amount we need to remember always. So see, 25 gram of bleaching powder is used. Bleaching powder means CaOCl2. This CaOCl2 is bleaching powder which is reacted with water and then paste is made. So 25 gram of bleaching powder, it is mixed with nearly 60 ml of water, so that a paste can be made of bleaching powder. So 25 gram of bleaching powder, 60 ml of water, it is mixed in a round bottom flask, and then after this aqueous solution of either ethanol or acetone, it is added in the flask. In this flask it is added the mixture of acetone or either ethyl alcohol. The aqueous solution is added slowly, means that aqueous solution of ethanol or acetone, it is added slowly. If you remember stepwise, it will be much easier to remember. Then the flask, it is heated on a water bath to maintain a constant temperature, bearable temperature. So after that, the chloroform which is formed, it passes through the condenser and it is received in a receiver. The chloroform vapors along with the water vapors which are formed, it passes through the condenser and then it's collected in the receiver. So this process is a distillation process. It means that the chloroform, it is received by distillation process. So this is about the procedure, and this will be enough. If you write in paragraph, it will be 2-3 lines, but in point, if you write, it will be easier to remember, and the probability of getting marks is also higher. Then finally, the last step of this, it is purification, because the chloroform which we obtain, they are mixed with the water and other impurities, so we need to purify it. Now this is one of the parts which you need to mug up in this. Now it's a bit tougher than other parts. These all are easy, it's just chemical reactions. You need to understand what needs to be removed and what needs to be added, but this part you need to remember some of the things. See, first of all, chloroform, remember that chloroform is separated by using a separating funnel. Now what is a separating funnel? It is a type of funnel in which if the chloroform along with the water is kept, then the water forms the upper layer and the chloroform forms the lower layer, because chloroform is heavy. So in this separating funnel, the chloroform being heavy, it settles down forming a lower layer, and the water along with other impurities, it forms an upper layer. Now what happens is that after keeping the chloroform along with water in the separating funnel, when the chloroform is obtained, now this chloroform, it is taken out and it is washed with NaOH, and then it is washed with water. These are the things you need to remember stepwise. It is washed with NaOH and then with water. NaOH is used in most of the purification processes because it absorbs other impurities, and water, we need to wash it with water. Now again, if we wash it with water, then moisture will be absorbed by this chloroform. So to remove that moisture and to make it anhydrous, we use CaCl2. This CaCl2, it absorbs all the moisture. Now finally it is redistilled, just to ensure that it is completely pure. It is redistilled over a temperature range of about 60 to 62 degrees Celsius, and finally the pure chloroform is obtained. Now these are the things you need to remember. First, it is washed with NaOH and then with water, and because the moisture is absorbed by the chloroform, then CaCl2 is used, which makes it anhydrous, and finally it is redistilled at a temperature range of 60 to 62 degrees Celsius. That's all about the preparation of chloroform or trichloromethane in laboratory, both by acetone and ethanol. Now I'm going to tell you about some of the important chemical reactions which will be asked along with this question. It may be or may not be asked, but still I'm going to tell you about some of the important chemical reactions of the chloroform. Now the very first chemical property of the chloroform is oxidation, which is one of the most important questions. This question is frequently asked, and the question will be asked somehow like this, that why chloroform is stored in a dark or brown colored bottle, or why chloroform is filled up to the brim of the bottle. Brim of the bottle means up to the upper limit of the water, or why some amount of ethanol is added with chloroform. All these three questions have only one answer, and the answer is that this chloroform, it undergoes oxidation by the atmospheric air in the presence of sunlight. It means the chloroform, it undergoes oxidation in the presence of atmospheric air and sunlight. After going into oxidation, it gives a very poisonous compound known as the carbonyl chloride, and this carbonyl chloride, which we call commonly, is known as phosgene gas. You must have heard about the phosgene gas. It is also known as the tear gas, and it is one of the most poisonous, highly poisonous gases. So this chloroform, it undergoes oxidation in the presence of atmospheric air and sunlight to give this phosgene gas or carbonyl chloride. For reaction, you can see CHCl3, which is the chloroform, it undergoes oxidation. So oxygen in the presence of sunlight, and oxidation with the atmospheric air. Atmospheric air means O2. So CHCl3 plus atmospheric air O2 in the presence of sunlight to give phosgene gas. Now the formula for phosgene gas is COCl2. What happens is that this hydrogen along with one chlorine, it gets removed. It means HCl gets removed and forms, the remaining one adds there, and it forms COCl2. Now you need to remember the formulas I told you earlier as well. The phosgene is COCl2, and this is one of the most important formulas as well. So you need to remember this. You need to mug up the formula for phosgene, COCl2. So this COCl2 is formed. Now this gives the answer to all of the three questions, that why chloroform is filled up to the stopper of the bottle or brim of the bottle, because doing that it does not come in contact to the air if it is filled till here. And another, it is stored in dark or brown colored bottle so that light cannot enter the bottle. So it will prevent the formation of phosgene gas. And the last one, small amount of ethanol is added with the chloroform. Why this ethanol is added? Because see, even if by mistake, even if the phosgene gas is formed, then what will happen is that this ethanol will convert it into diethyl carbonate, which is non-poisonous. How? See, we know that phosgene gas is CaOCl2. Now if you draw the structure, it will be somewhere like this. OCl will be 2 Cl2 and OC. It is also a type of ketone. Now if you add the ethanol, now we know ethanol is what? It is ethyl alcohol, so it is CH3CH2OH. So if we add, now while writing this, write it somewhere like this, HOCH2, write opposite, CH3, HOCH2CH3. Now if you do this, this chlorine and hydrogen will react, and it would form HCl, 2HCl, and the remaining one will add there. So it is easier, just add the remaining one. O will be there, CH2 CH3, again OCH2 CH3. Now this compound which is formed, it is known as diethyl. See, 2-ethyl is there, CH2 CH3, 2-ethyl carbonate, because it is formed from carbonyl chloride. So it is known as diethyl carbonate. Now this is formed whenever phosgene reacts with the ethanol. So that's the reason why small amount of ethanol is added. When this question will be asked, why the small amount of ethanol is added, you need to show this reaction as well. It is easy to remember, just you need to remember how to write the structure of the particular molecules. And that's all about the oxidation. This is one of the most important. Now we'll be going for the action with acetone. Now it is also one of the most important reactions. It will be asked somehow like this, that how is chloritone prepared, or what happens when the chloroform reacts with the acetone. So remember that whenever it reacts with acetone, it will form chloritone. And chloritone is another important term to be remembered. There are three terms to be remembered which are very important in chemical properties. First of all, phosgene I told you, chloritone, and one more is chloropicrin. I will be telling you about the chloropicrin, but another is chloritone. So what happens is that this is formed when acetone is reacted with chloroform, and whenever acetone reacts with chloroform, chloritone is formed. It can be asked anyway. So remember, acetone and chloritone, they are interlinked. So whenever the chloroform, it means the CHCl3. Now see, we will be drawing structure wise. So cut this, draw the structure wise. First of all, acetone. So we know acetone is the same thing from which the chloroform was prepared. The same acetone which is known as CH3CCH3O, if you remember the formula. So first of all, we will write the formula. So it is CH3CCH3O, and it is reacted with the chloroform. And while writing this reaction, write hydrogen CCl. Now it doesn't matter, you can even write CHCl3, but for making you understand, I am writing this way so that I can show you the mechanism how the chloritone is formed. So now what happens is that when this reacts in the presence of KOH as an alkali, it means potassium hydroxide, it happens to be that hydrogen goes and adds in oxygen, and this whole CCl3 it goes and adds to this. So it is easy to remember, hydrogen adds there and CCl3 adds there. If you make the structure in this way, so it will be, see, hydrogen adds there, so it will be OH. Now you don't need to write the double bond because one bond will be with hydrogen, so single bond, and then CCl3 adds here. So this is the structural formula for chloritone, and this chloritone, it is a sleep inducing drug. Okay, this is an extra info that it is a sleep inducing drug. Now this is about the chloritone, and remember the formula of chloritone because sometimes it may be asked what is the structural formula of chloritone. So if you do not remember, you can even remember the process of making chloritone means it is similar to chloritone acetone. So you can remember that whenever chloroform, it is reacted with acetone, it forms chloritone. And if you write the structural formula this way, it will be much easier to understand. Now that's about the chloritone. Let's go on for chloropicrin. Now as we remember that acetone and chloritone, they are interlinked, we need to remember that chloropicrin is formed from nitric acid, the conch nitric acid. Okay, now remember chloroform is formed from conch nitric acid. What happens when conch nitric acid is reacted with chloroform? It forms chloropicrin. How chloropicrin is formed? When chloroform reacts with nitric acid. So remember they both are interlinked. Easy, acetone, chloritone, chloropicrin, nitric acid. So this forms by nitration process. Usually nitration is a process in which the hydrogen atom of a benzene or of an acetaldehyde or any compound, the hydrogen atom present in the compound, it gets removed and it is replaced by the NO2 present in the nitric acid. Nitric acid means HNO3. If you write, it will be HONNO2. Okay, the structure will be somewhere like this. So this is not the structure, just the writing way. So this NO2, it replaces the hydrogen atom, just to make you understand. So what happens in this is, now again you can write the simple structure as well if you want, CHCl3 plus HNO3, but to make you understand I am writing the structure in such a way that you can understand. So I am making the chloroform this way, 3 chlorine and 1 hydrogen, okay, plus, and if you want to write the similar way as I am writing, then you need to remember in which formula it is written in which way. In acetone it is written H separately and CCl3, and even here you can make this formula somehow like this, like CCl, Cl and Cl. There is no big issue in this, but then again while adding here you need to write CCl3 only, so I wrote here CCl3, simple. And then in this chloropicrin I made this hole to make you understand the structure of the chloropicrin. So what happens is that HO and NO2. So here what happens is this hydrogen atom gets removed and nitrogen and oxygen, it means nitrite of this, it replaces there. So it will form, I'll draw here, Cl, Cl and Cl similar, and NO2 comes here, so NO2 plus H goes out and HO is there, so H2O. So this structure is known as chloropicrin. Cl, Cl, Cl and NO2. This is known as chloropicrin. Remember the structure of chloropicrin. Remember the structure of chloritone. Okay, and remember acetone is from chloritone and chloropicrin is from nitric acid. And also remember the phosgene. These are 3 main chemical reactions of this. The other chemical reactions are not that important, just at a glance you can see it, but usually it is not said. Usually these chemical reactions are asked, and one more, the Reimer-Teimer reaction, but that's not much important. Still I'm going to tell you about the Reimer-Teimer reaction. It's your wish if you want to remember that or not. So this is the chemical reaction in which salicyaldehyde is formed. Now salicyaldehyde is a common name, and scientifically it is known as orthohydroxybenzaldehyde. Okay, now basically it is not asked, but whenever it is asked how salicyaldehyde is formed, when to write that it is formed by Reimer-Teimer reaction. Remember, Reimer-Teimer reaction means the action with phenol. Okay, the action with phenol. Phenol means this benzene and OH here. So this is the phenol. So whenever chlorine chloroform. So whenever chloroform is heated with this phenol and the sodium hydroxide, it means aqueous NaOH, at about 60 to 70 degrees Celsius, which is followed by hydrolysis in acidic medium, means hydrolysis in acidic medium. So then salicyaldehyde is formed. Now I'll show you what is this all things. So first of all, draw of phenol. Now it is reacted with the chloroform, it means CHCl3. So whenever it is reacted with CHCl3, the chloroform goes and add here. So OH and chloroform goes and adds there. So CHClCl. Now chloroform is ClCl, 3 chlorine and 1 hydrogen. So in place of 1 hydrogen, this hydrogen of this benzene ring is there. So 1 hydrogen goes out, and the hydrogen of this benzene ring, in place of hydrogen of the benzene ring, this carbon atom is attached. So if you see the structure, actually it will be some H, and then CCl, Cl, H, and here it is O added. If you see the real structure, it will be somehow like this. It means that the chlorine of this, 1 chlorine of this and the 1 hydrogen of this, it removed. So minus HCl is removed. Okay, with this HCl is removed. You do not need to write this, I just told you for information. So what happened is that in place of this hydrogen, CCl and H is there. So after this, it is reacted with NaOH. So when this structure which is formed, this structure which is formed, it is reacted with aqueous NaOH at about 60 to 70 degrees Celsius. Then the OH of this, it replaces both the carbon atoms. This is not only one molecule of NaOH, there are 2-3 molecules of NaOH. For instance, we'll take 2. So this OH of this replaces here, and Na will replace this hydrogen. You need to remember this. So I said that it is not important, it's not regularly asked because it's a long process. So in place of hydrogen, Na is there, and in place of Cl and Cl, OH is there. OH, OH and H. So this type of structure is formed after this, after reaction with chloroform and NaOH. The Na there, the OH in place of chlorine. So after this, it is done hydrolysis. So it is followed by hydrolysis. Hydrolysis means the removal of water. So removal of water from this, it means that H2 is removed, 1 hydrogen and 2 hydrogen and 1 oxygen, H2O, it is removed. So when H2O is removed, hydrolysis, the structure will remain somehow like this. Only 1 oxygen is left, 1 hydrogen is left. So the double bond will come here because carbon is a tetravalent molecule. So double bond will come here. So this structure. So finally the hydrolysis is in acidic medium. Acidic medium means HCl. So when hydrolysis is done in dilute HCl medium, then what happens is that this HCl generates H plus ions. So this H plus ion goes and replaces this Na, and that's all. Means that H will be here and CH. Oh, now this is known as salicyaldehyde. So basic structure of salicyaldehyde is this: OH, phenol, draw a phenol and add CHO. This is the salicyaldehyde. It means that add aldehyde in the benzene ring, of phenol. Very easy. So this is known as salicyaldehyde, and scientifically it is known as orthohydroxybenzaldehyde. This is hydroxy. So this is hydroxy, and this is aldehyde in the ortho position. This is meta position, and these are ortho positions, isn't it? This is meta position, and these are meta position, and these are para positions. So in ortho position, the CHO is added. CHO means aldehyde, and hydroxy is there, so it is known as orthohydroxybenzaldehyde. So basically what happened is that, first of all, the phenol, when it is reacted with CHCl3, the CHCl, the 2 molecules of Cl along with the carbon and hydrogen, it added there. It means, remember that HCl is removed. chlorine from this and hydrogen from this. It goes and adds here, and after that what happens is that it reacts with NaOH. It means Na replaces the hydrogen, the OH replaces the chlorine. So this type of structure is formed. And in hydrolysis, water is removed, so H2O is removed. It means this only this much is remaining, and in acidic medium, H plus ion is formed, which replaces the Na ion. So OH, finally this OH is formed, but in place of CClH, CHO is there. This is known as salicyaldehyde, and that is the Riemann reaction. It is a long reaction. And that's all about the chemical reactions of the chloroform. Thank you for today, and do not forget to subscribe the channel.